got another example here, just dealing with simplifying radicals. So my goal is to try to simplify as much as I can on these. So simplify each individual radical as I go along, and then combine like terms or combine like radicals. The square root of 50. Hopefully, we should notice that the square root of 50 actually factors down into the square root of 25 times the square root of 2. The square root of 25 is actually 5, so I have 2 times 5 times the square root of 2, which is 10 square roots of 2. So that term simplifies down to 10 square roots of 2. So notice I'm going term by term here when I simplify, and then at the end maybe I can combine like radicals. The similar thing here, what's the square root of 500? I know that 100 is a perfect square, so I guess I'll have 4 times the square root of 100 times the square root of 5. So I know that 100 times 5 is 500. Split that up, I get 4 times 10, because the square root of 100 is 10, as the square root of 5. I get 40 square roots of 5. Okay, and these are not like terms, so I can't really combine them, because they have different radicals. Let's see what happens here. I have negative 6, so I have 6 times the square root of 25 times the square root of 5. So I end up getting the square, or 6 times 5, because the square root of 25 is 5, times the square root of 5. 30 square roots of 5. So, in the long run here, simplify. Not these right here are like terms, because they have the same radical. Okay? So I can actually combine those and call that, I call that 10 square roots of 5. Alright? Plus my 10 square roots of 2. And I'm done. That's my final. This thing up here, this simplifies to that right there. This one. Now notice that I'm multiplying right here. Notice I had 2 terms and 2 terms. So this should actually relate to what? FOIL, exactly. Definitely relates to FOIL right here. FOIL. Okay? I FOIL this out. No big deal, okay? So I'm just going to go ahead and write it all out. That would be kind of the best way of doing it. And, until we get good at multiplying radicals together. This is what I suggest that we do. So FOIL, first term's 2 times the square root of 3 times the square root of 3. That's this times this. Outside terms is 2 square roots of 3 times, since plus, so 2 square roots of 3 times 2 square roots of 2. And then inside terms, negative times positive would be a negative, so I have negative 4 square roots of 2 times square roots of 3. And then finally, last terms, negative 4 square roots of 2 times 2 square roots of 2. Barely had enough room. Made it on there though. Okay, so now I go through and I simplify each individual, notice each individual product in here. Okay? Simplify it. Anybody know what a square root of 3 times the square root of 3 would be?
2 square roots of 3.
No, when I take the square root of 3 times the square root of 3, that's actually the square. It's actually the square root of 9. Well, what is the square root of 9? 3. So, a theory here is whenever you take a square root times itself, what are you gonna? The square root actually undoes itself, and you just get the number that's inside. Okay. So that's actually happens here. So what I get here is 2 times 3, which is just 6. Okay. Again, square root of 3 times the square root of 3 is actually the square root of 9. The square root of 9 is actually 3. 2 times 3 is 6. Product here, I have 2 times 2 times the square root of 3 times the square root of 2. So I'm going to get, what, 4 square roots of 6.
You can't do that.
Yep, you can do that.
Well, if it's 2 square roots of 3 times 2 square roots of 2.
Why not? It's a product.
Aren't they 2 different? I thought they were 2 different things.
They're radicals, aren't they? Follows the rule. You can do that. Simplifying. Simplify this one right here. I get what? Minus 4 square roots of 6. Minus. Same situation as happened at the beginning here. Square root of 2. I guess suppose I write this out. I have a minus 4 times 2 times the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is actually 2. Times 2 times negative 4. I get, well, it's going to be a minus 16. What happens to my 2 middle terms here?
Cancel out.
Holy cow, they cancel out.
Answer's
6 and negative 16 is actually a negative 10. Okay, it's notice I have a kind of a fraction or a rational expression with a numerator and denominator. Okay, so what I need to do here to simplify this, I need I call it rationalizing my denominator. Okay, I need to get rid of the square root in the bottom. I can't have a square root in the bottom to be simplified. Okay, now to do a problem like this, what I need to multiply the bottom times is what I call its conjugate. A conjugate is the same 2 terms, but it's the opposite sign. So it's kind of like a sum and the difference of it, or if this case, if this is the difference, you want to multiply it by its sum. That's called a conjugate in the terms of radical symbols or radical expression. So if I take the bottom times this, I also need to take the top times the same thing. Okay? And so notice that what we're doing here is we're doing a little bit of foiling, like what we did the last problem, which is no problem, especially when I notice that if I'm taking the foiling a sum and difference in this particular situation, all I really need to worry about, because if I know I'm foiling a sum and difference, the one thing that you should get notice about that is that you only need to worry about the first terms and the last terms, because what happens to the O and the I? If I were to take m squared times m minus 2, and I were to FOIL that, what happens to my O and my I of foiling?
They're the same variables.
They're the same, right? But what happens to them? So my outside terms, I have negative 2m. My inside terms are positive 2m. They cancel out. Same thing happens up here. So I don't need to worry about those two. Just if you know that you're multiplying or foiling together something like this, don't worry about O and I. Just worry about F and L. Okay? Okay, so in that particular case, I know that 3 times 3 is 9. I know this is going to be a minus because it's a sum and a difference. A minus square root of 5 times the square root of 5. It's actually just 5, right? So the bottom part here is equal to 4. Alright, 9 minus 5 is 4. The top part is what's going to be the tricky part. And that was one of my goals too, right? I want to get the square root out of the bottom of the denominator. I don't want a square root down there. The top part is going to be the tricky part. 2 times 3 is my FOIL. That's my F. My outside terms is going to be a negative 2 square roots of 5, because 2 times the negative square root of 5 is negative 2 square roots of 5. That's my outside terms. My inside is going to be a negative 3 square roots of 5. And then my final terms is going to be a plus 5. So I have 6 minus 5 square roots of 5. Notice this, I combine these. It's like saying I have negative 2x and a minus 3x. I just get a minus 5x. Kind of think of it that way. Combine those. Plus 5, plus 6, plus 5, I got a plus 11, so I can actually change this to a plus 11. I have 11 minus 5 square roots of 5 on top. 11 minus 5 square roots of 5 on top. All right, here's a quick snapshot of 4 try this problems that you should add to your list. So the square root of 75, x to the 4th, y to the 7th. This is right. This is the square root of 75. Just making sure that you can read this.